off of there, but it's not flopping around. That's what's going on here. There we go. Yeah, that's pretty good. And if I drop this, see, it's good shape. Okay. So I'll put my heating mantle back up, and I'm going to leave this set up for you. So we've got that. Now I'm going to put the column in, this thing, to do separation. I'm going to use a condenser as a column. I'm going to pick this one. Doesn't really matter. It's just a glass tube. We can just use a plain old glass tube if we wanted to. And he'll set in there all by himself. Gravity holds it. There's no need to do anything. Do not clamp this as opposed to the flask, because if I drop the mantle and I was holding on to this, what's going to happen to the flask? It's going to go down too. Now I need to measure the temperature of the thing, so I've got a little thermometer adapter. It's got a rubber collar on it. I've got to stick a thermometer through here. The thermometer needs to go through that rubber stopper. Little tiny bit of stopcock grease, essentially Vaseline. Little teeny tiny bit. Don't try to push it straight in. Twist it. Get your hand close to it when you do that. Don't push way out here. It's easy to break it. Do that. And if you break it, the likelihood is this piece will go right into your hand. And then we'll go right down to campus safety, and then you will go right over to the hospital. And that's what happened last year. So I just sort of twist it like so. I'm putting him down in here. And then I'm going to set this guy on there. I could measure the temperature, but I have just generated what's called a glass hand grenade. Because when I heat that, it's closed. Boom. Something's got to. Oh, well, okay, so that can't be right. Oh, I got to redirect it anyway. So that doesn't want to be on there like that. I need a redirector, a distillation head, and that's this. It's called a simple distillation head. Put that on. Gravity takes care of it. No problem. Put this on. Then I need to place the thermometer, and I need to place the thermometer to get the temperature of the vapors that are coming over. So they're going to be coming up, and they're going to be sneaking over right here, and I got to get their temperature. So I want the bulb split right there, just like that. Pretty close. Maybe it needs to come back up just a little tiny bit. Yeah, that's almost right. I'd like him up just a teeny tiny bit more. The low range thermometer, so that the range you're interested in isn't hidden down in here. Yep, I think that's pretty good. Now the thermometer is going to read the temperature that I want it to read relative to where it is in the apparatus. Now I got to condense it. No water going through this. If I did, this whole thing would be at room temperature. I don't think that's what I want. Right? I want this gradient. So I need a condenser to put on here. That'd be this guy. Put him on now. Whoa, wait a minute. Gravity. This guy's going to have to be secured somehow. If I just push and twist very gently, there it is. It's not going to come off of there. Don't trust that. Don't trust that. Get yourself one of these yellow clips. Big C-ring, little C-ring, big joint, little joint. Made them up. Boom. Now I would not even have to twist it. I'd probably like to, and I'm ready pretty much. It's going to drip out here. I'd actually like to direct it more intentionally. I'll use this guy, put him on. Likewise, he would fall right off, a little tiny twist, and he's, but I don't think I want to take a chance on that because this is going to be heating and cooling, and no, I'm going to clip it. So I got that, good. I'm going to have to collect if you look at what the experiment's going to be, we're going to follow the temperature every 2 milliliters throughout the distillation. So I need some way to measure the volume that's coming over. 50 mil graduated cylinder. Oops, where'd he go? I need him. I got it. I'm going to want this over here, so I can measure each 2 mils that comes over. Probably need some way, because I could be a good use for your organic book, I guess, since you probably aren't going to read it. Can you believe that people 2/3 of the way through intro chem will come in and they're struggling with the course and they will say, I don't know, do you think I should read the textbook? Maybe. You really wonder. You really wonder. I hope none of you are walked into Mrs. Doctor or somebody else and said that, but probably somebody in here did. Don't bother with me. That'll be fine. Now I've got it just up a little bit. I can get it off of there real easily. But if I inadvertently just bump that a little bit, it's not going to go anyplace. So that's a nice way to set that up. This is going to be a condenser, so I need water in there. Condenser tubing, that's this size tubing. It goes on. The best way to lubricate this is not with stopcock grease, because it's going to go on one of these little things, right? It's not with stopcock grease, because that'll permanently sit there. You get pressure, it'll blow it right back off because it's greased. Instead, what you want is a little bit of water. I don't have any water. That's my tea. Spit is probably the best lubricant for it. Slips right on there. Don't you put it on that way. Put it on by like that, but stay away from this clean tubing. Spit in it. And it slides right on. Just like with stopcock grease. But the spit is water soluble, and it'll wash off of there very quickly and won't pop off. Okay, so there I am, and then I just have to decide, well, one of these is going to go to my lab partner's hip pocket, the other one's going to go to the faucet, which is which. If this went to the faucet, I'd create a waterfall. It would be cute, but it would not fill this with water necessarily. So the bottom one goes to the faucet. So it's always, for a condenser, water goes in the bottom, out the top. So that's set up fine. That's all good. I need heat source. Well, I've got the heating mantle over here. Power stat, just like a rheostat on a light. Power stat is what we use. There's the knobby part of the thing. It has an on-off switch. Actually, this one has two different voltages. It's a step-up transformer. It's 120 or 140. I'll pick 140 eventually, but it should be off until I'm ready to go. So that's here. It's got a plug here that presumably connects to that. It's got a plug here that goes to the wall. Just looks like a regular plug, so that goes to the wall outlet. If you look at the heating mantle, the plug on it has curved prongs. This has standard straight prongs. This goes on here, and it has a big one and a little one, so you got to line those up. Which one's the big one? That's the big one. And that goes on like so, and then this, and do not plug this into the outlet, because you'll get full voltage and you'll burn that $125 mantle. So unless you want to buy a burned out mantle, I would not do that. Plug it in here instead, and then you're pretty much ready to go. Okay. So to start up the distillation, what you would do is turn this on and then turn this rheostat, it's called a variac, but turn this rheostat up to about 70%. And it'll start to heat up. And you'll know it's heating up because this will start to get warm. You will look at the liquid. You'll see convection currents in it. Eventually you'll start to see bubbles. Then you'll see those vapors coming up and condensing, and you'll get a liquid vapor ring, and you'll see that climb up and climb up. During all that process, this thermometer won't do much of anything. As soon as that vapor ring, liquid vapor ring, gets to the bulb, then your temperature will go up. Then it'll come, that interface will come out, the liquid vapor interface will come over here, and you'll start to condense and start to run down. I asked you to bring your handout, your lab handout with you, because what you need to look at right now is, there it is, this. So find this. It's the page right after a diagram that looks like that.
Is this within the handbook?
It looks like that.
Dr. Smith? I have money for the handbook today. When can I get that from you?
You can follow me back to my office right away.
Okay.
Okay? So find that. Everybody see that? You can see there are 3 columns. No, there aren't. There are only 2 columns. This, for you, right-hand column does not exist while you're doing the experiment. Ignore it totally. Ignore it totally. If you look at the left-hand column, it's going to tell you what you see with regard to your apparatus. And in other words, at a certain point, record a temperature. And here's where you record the temperatures. Okay? Now, what we're doing is monitoring the temperature throughout the whole distillation, well, almost up to the end. Throughout the distillation, every 2 degrees, and every 10 milliliters collecting a 2 mil fraction, starting with the first 2 mils that comes over as a fraction that we're going to analyze. We'll do that in test tubes, little test tubes like these. You're going to be doing either a simple or a fractional distillation with your partner. Your one group is going to do one kind of distillation. So we'll say this hood, you're going to do simple. This hood, you're going to do fractional. And a pair of you will do that type of distillation, whichever it is. This was set up for a fractional, which is what the fractional distillation is. Simple distillation setup is exactly like this, except this isn't here. Okay? So this can actually, for that, be a little higher, and that can actually sit on the floor of the hood. Okay, if you adjust the height of this right. You'll have to play around with it once you get it put together, but that would work fine for a simple. So simple does not have this, otherwise it's exactly the same. So I get test tubes now. I want to, before I start, I want to get myself 5 test tubes. I want to label them SA through A, B, C, D, E, or F, A, B, C, D, E. So I get my 5. 2 mils is going to go in here. This is not graduated, so before you get started, take 2 milliliters measured in your 10 mil graduate. Take 2 milliliters of acetone, pour it in one of these test tubes. Make a black mark. That's what 2 mils looks like. Take your other test tubes, line them up alongside of it, transfer that mark along. Now you know what 2 mils looks like. So now I'm ready to start my distillation. I turn my power on. I turn this up to 70. Before I turn the power on, I get your instructor to come over and sort of check it just to make sure everything looks okay. Main thing is they're going to check your thermometer and that you got water running through it and whatever. Now the distillation is kind of going. It's finally gotten hot. I'm beginning to see some liquid come down. And the chart tells me the first 2 mils into test tube A, and then I write the temperature. So I'm going to collect 2 mils, not in that, but in this, and then write the temperature. So the first temperature gets recorded at the end of the first 2 mils. Every temperature gets recorded at the end of the collection of 2 mils, either in a test tube or in the graduated cylinder. So, okay, it looks like it's about ready to come over. I'll now get my test tube. By the way, you're going to need these. This is what we'll analyze the solutions on the GC. You don't want them to evaporate because it'll be the following week probably before you get to analyze it. So it's got to be corked. Corks are porous, and therefore we've got aluminum foil on the bottom of the cork like so to seal it. And then at the end of the distillation, all those test tubes with your name on the beaker go in a beaker in the refrigerator, and then you come back when you're going to do the GC analysis of it. Okay? So we got that all set up like that, and it's running. I'm ready to collect. I take FA or SA, and then I hold it. Now, you don't just turn this on and then stand there and hold this thing, because you're going to be standing there and holding it for about 20 minutes before anything happens. So you just kind of watch the apparatus, and when you see that ring get up here and the temperature's going up and I'm beginning to see, oh yeah, it's condensing over here, then I think I better get my test tube and hold it over here. And I wait and I collect 2 mils in it. At the end of collecting 2 mils, I read the temperature, write it down, cork this, put that up, and I'll collect 2 mils in there. And then I'll write the temperature down again. Then I'll collect 2 more mils in there. It'll read 4. That's what this is showing us. And then it'll read 6, and I write a temperature. And then 8, and I write a temperature. And then 10, and I write a temperature. Then I get the next fraction, FB. And I collect its 2 mils, and I write that temperature down. And then I put this back over. It still has 10 in it. Collect 2 more. It now will show 12. And I write the temperature. So this is what you want to follow, and you write the temperature at the end of each 2 mil thing. Okay? Do that in your head multiple times. See yourself doing it. Look at the thing. Look at your apparatus, or look at the picture of the apparatus. See that happening so you don't get out of sequence. Because if you get out of sequence, you have to pour it all back over and start over again. You don't want that. So that's pretty much it. When you finish, if you add all that up, you're still going to have about 10 mils in here. That's so that we don't distill this to dryness. Because if you do that, 1, you could burn out the mantle. 2, you could blow up the apparatus if oxygen goes back in. So you'll have almost 10 mils left in here when you are finished. Okay? Make sure that you are on time for lab next week, because although you can come early and start to set up, that would be fine. But at 1 o'clock, what we will do is take you over first and show you how to use the GC. Because it's more sophisticated than just there's the box and here's the needle and stick it in. Okay? You're going to learn how to run the GC. And then you'll come over and finish setting up your apparatus and doing the distillation. Yes?